Work it, make it, do it, make sense.
Welcome to this afternoon session. I like to call it Services Assemble. You'll see soon why. Or more in depth, applying minimum viable product principles to create cutting-edge microservices without chaos, hopefully, using Spring Cloud and Netflix OSS. I'm Mark Heckler. I'm a principal technologist and developer advocate with Pivotal Software, Inc. Pivotal are the makers of good stuff like Spring Framework, Spring Boot, RabbitMQ, Redis, Greenplum, Cloud Foundry, huge contributor to Apache Tomcat, and a handful of other things. We like to say we're a tiny little startup in Silicon Valley. Not so tiny, but pretty nimble still. I blog semi-regularly at thehecklers.org, and I tweet very regularly at mkheck. Is anyone here on Twitter? Okay, a couple people. That's not bad. Highly recommend Twitter. It's got a high signal-to-noise ratio. It's not like there isn't a lot of noise, but you can filter it out pretty well, much better than those other social networks. So I'm kind of fond of it. And I live on Twitter from kind of sun up to sundown and a lot of time in between, even sometimes lying in bed and tweeting. So, for what it's worth. I have no life. You'll see that soon. But for those of you who are not on Twitter, I'm also a member of the slightly older and more established social network called Email. Is anyone on Email? Okay, a couple more, yeah. I, like everybody else, have a half a dozen email addresses, so I always just point to my personal one, mark@thehecklers.org. It's easiest to remember. So if you have questions, comments, feedback, whatever, I welcome those. If they don't fit into 140 characters, or if you just hate Twitter for whatever reason, feel free to email me. I don't check it as often as Twitter, but I do check it periodically. So who am I? Well, I'm the author of several blogs and blog posts. I've co-authored one book. I have another one in the planning stages, as well as a couple other neat projects. Hopefully I'll be able to bring to fruition by the end of the year. I'm a frequent speaker kind of around the world. Thanks for inviting me here. Thanks for inviting me back. I mean, I can't believe it. I got to come back. That's great. DevOps UK is a really great conference, as you all know. Is any first-timers? Okay, that's cool. Come back, because it just seems to get better and better. And as you're seeing, it's a very well-run event. So I am a developer, obviously. And as you can probably tell from the next bullet point, what most of my expertise is in, Java. I was recognized last year as a Java champion for contributions to the greater Java community. So if you had anything to do with that, thank you very much. I really appreciate it for the vote of confidence. And as I like to say, I'm a survivor of many monoliths. I was a reluctant convert to microservices. When you are familiar with something, you know all of its good and bad, you know the warts, you know where the bodies are buried, you become pretty comfortable with it. And I'm a human being. And all human beings typically resist change to some degree. So I say I'm a reluctant convert, but I am a convert. And I think there's very, very good reasons to be excited about microservices. As well as a seeker of a better way, which that kind of ties in with the previous point. So this is what we're going to be talking about today, right? I think this is a great example of microservices because you have very distinct capabilities, very distinct units that all come together, and you've probably heard the expression the whole is greater than the sum of the parts. When you try to If you were to try to create one giant superhero, is anybody here a comics nerd, please? Anybody? Oh, wow, okay. I was hoping for a better response than that. This is just, it's going to go downhill from here, folks. But if you were to design one massive superhero who did everything, we'll call it Monolith Man, or Monolith Woman if you choose. It becomes pretty difficult to kind of ball it all into one. And it probably is not going to do all things equally well, right? When you bring unique strengths to the fight, it actually helps to accomplish far more than you would expect. And that's my shameless tie-in to the Avengers. Love the Avengers, as well as a few other players here. So anyway, who here is a Java developer? Wow, that's great. That's so awesome. Anyone use Spring? Yeah, also good. Spring Boot? JavaScript? Oh, come on. And you fell for it. Turn yourselves in. Just leave now. I'm just kidding. Is anyone here familiar with 12-factor apps, the 12-factor manifesto and what have you? Okay. Concept of cloud native? Okay. I just kind of like to gauge kind of where everyone's coming from. let me provide a little bit of context. With a monolith, I'll shamelessly steal one of Adrian Cockcroft's statements. I've said it many times, but he's far more important than I am, so it sounds better to actually attribute it to him, which is true. He said, monoliths only appear simpler from the outside. Because if you have a problem with a large monolithic system, you know where the problem is. It's with the monolith. When you have a problem with a distributed system, you don't always know where the problem is. It's not always easy to find where the problem is. So it adds a great deal of complexity, at least from the outside looking in. From the inside looking out, it actually simplifies things greatly, as hopefully we'll see as we go through today. I work for Pivotal. Pivotal contributes greatly and stewards Spring Boot, Spring Cloud, a lot of other things, as I mentioned. The Spring Framework came into being because enterprise Java was very difficult and cumbersome to use in the old days. If anybody's a survivor of that, I won't ask you to incriminate yourself, but you're probably silently nodding to yourself and weeping as I say this. Spring Framework came into being to address some of those issues. But over time, of course, the Spring Framework grew and expanded to take on a lot of capabilities. And over time, of course, it kind of gathered the reputation as well as being rather large and cumbersome. Maybe unfairly, but it is what it is. In 2013, I guess it was, Spring Boot went general availability. Spring Boot is sometimes referred to as a micro framework. I really hate that term, but I can't think of a better one. So we'll go with that. But in essence, it allows you to take all the capabilities of the Spring Framework and more and put it in and bundle it in a very easily consumable package for developers. So it gives you things like auto configuration, which makes rational judgments based on things in your class path and your code and your annotations in your code to kind of determine what you might need in terms of supporting beans to provide the capabilities you want to provide for you. You can override anything, but of course it gives an opinion. It says, hey, if you have this in your class path and you have this in your code, we kind of figure you're going to want that. So it dramatically speeds things along. It also gives you the ability to clean up your dependencies, much more rigorous dependency management, version synchronization, things like that. So it really does allow you to go from 0 to app in under 5 minutes. It also brings everything together neatly into a fat jar. So you can have nested jars, not shaded, which brings its own set of problems as well, but allows you to deploy your application as one unit anywhere there's a JVM. So it simplifies that a lot as well. Spring Cloud, as it says, is designed for fragile infrastructure in partnership with Netflix. Now, Netflix sometimes will produce something right out of the gate and open source it, but Netflix deploys specifically, at least to date, on Amazon Web Services. So many times our engineers will work after the fact with something they've produced or work with them from the initial stages to produce something that has broader applicability and release it under the Spring Cloud name as well. So we love Netflix. They have great stuff. It has a lot of applicability. Hopefully we've expanded that as well. I'm not going to go too much more deeply into that because time is short. And I'd like to get into actually showing you some of these concepts because I think they make a lot more sense when you see them in code. I will say that I've got a lot of material I would love to cover. So thanks for signing up for the 3-hour session. I really do appreciate that. I'm kidding. It's only 50 minutes. 2 points. 50 minutes is a very short time. So I'll be covering a lot of things, as many as I feel like I reasonably can cover pretty quickly. But our time afterward, that's the bad news. The good news is our time afterward is nearly infinite. So if you have any questions, comments, feedback, maybe I covered something too quickly for your taste, that's great. Maybe I didn't like how quickly I covered it either. Please just let me know. Ping me. Happy to discuss this at length afterwards, tomorrow, anytime in the future. That's perfectly fine. I will warn you right now, my wife tells me that I am unintentionally funny, meaning I'm only funny when I'm not trying to be. And I do have a few, I think, humorous remarks thrown in here. So I'm warning you now, you'll probably groan. But if you groan, I take that as a positive feedback too, so that's fine. And if you do throw out a pity laugh, I take that as well. So some of the components that you typically need. I mentioned enablers. When you deal with a microservices architecture, I feel like there are two kinds of enablers that you really need to get your hands around it. One kind of enabler is the enabling component that allows your microservices to interact with each other. And the other side of that is an enabler that helps you to reason about and manage and monitor your microservices so you know what's going on in your system. You'll actually find some components do both, and I'll point those out as we go as well. But you definitely need both, because otherwise you have this dysfunctional system that doesn't talk to itself when you look at it in the macro level. So we start with centralized configuration. Now, we don't want to insert a new bottleneck. We don't want to distribute a monolith, right? So we need some mechanism that helps us to manage our configuration without inserting a new bottleneck into the entire system. If you have one massive monolith, you may have configuration strings set up within your code. That's not great, but it's a monolith, so they're in one place. You may have externalized them into your environment. That's better. But when you have multiple microservices with multiple instances of each, that gets to be really cumbersome to try to manage yourself. So a centralized configuration resource gains you a lot of manageability as a human being. We typically point to Spring Cloud Config. Spring Cloud Config will read in properties, usually key value pairs or YAML, whatever format you prefer, and use that to supply configuration settings to any of your microservices that contact the config server for that kind of configuration. Spring Cloud Config obviously is dealing with text, key value pairs basically. So how do you version control that? How do you audit that? We do that all the time with our code, right? It's just text, so why not a DVCS? Spring Cloud Config can rest on top of a Git repository, SVN, console. Doesn't matter. It's just there to supply those configuration settings to your microservices. I'll show you that as we go too. That's one of the 12 factors, right? Externalizing your config. Service registry and discovery is typically provided by Netflix Eureka. There are other options, again, console, Zookeeper, what have you. But you need the key point is that you need some mechanism for your microservices to see and be seen by other microservices. In the old days does anybody remember the old days of phone books? What, 5, 6 years ago now? Wow, that's so old. With a phone book, when you went to a new city and you knew a friend there, you'd look up their name in the phone book, find their number, and then you'd pick up this old-fashioned device and tap in some numbers and you call them. The phone book didn't provide the conduit for communication. It just provided the lookup, and that's what a service registry does. It's not an ESB. It just provides a running track, allows you to keep a running track of where your microservices are running at any point in time. If you have 10 instances of a particular microservice running and one fails, your platform will probably, hopefully, spin up another instance to replace it. It may not put that in the same place. And you need some mechanism for your other services to be able to discover where those locations are and to access them. That's your service registry. You also have things in a distributed system that you will need for robustness, for resiliency, things like a circuit breaker. And just like your house, if you have a wiring issue in your master bedroom, hopefully you'll just lose power to your master bedroom. Maybe you'll lose power to your house, but hopefully you don't lose your house, right? So it allows your capabilities to gracefully degrade, and that's what a circuit breaker does. Netflix has Hystrix, and I will show you that as well here shortly. But it allows you to set multiple levels of degradation, so you can continue to keep the lights on and running, even as parts of your system may be failing and then coming back online. Netflix Ribbon provides a load balancer, a client-side microservice load balancer. That's important so we don't insert a new bottleneck. Once again, not that server-side load balancers aren't important, but this is what we're going to be focusing on today. And then, of course, your intelligent routing, which allows you to externalize your routing, so you're not embedding locations of backing services within your consuming microservices code. Because if that happens and something fails, you have to do a rebuild, retest, redeploy just to rehome to a different data store, for instance. Also, things like asynchronous messaging provided by Spring Cloud Stream, distributed tracing, very important, again, because if something fails, you need to know where it is, or if it's just slow, you need to know where the slowdown is. And of course, security, with Spring Cloud Security providing capabilities, authentication and authorization, and much, much more. Now, again, our time is very limited, so I'm not going to be covering all of those, even cursorily. I just wanted to kind of point out some of the minimum things you need to consider when you're talking about a microservices architecture in order to get started. So let's smash this, right? Okay, so let's do some coding. I'm going to switch over to mirror my screen, hopefully. if all goes right. Boom, boom. Oh, much better. Okay, so we'll leave that like that. Let's see, we'll center that. And actually, let's blow that up a little bit. Let's just maximize it. Boom, okay. And we'll maximize that. And that is just not readable, so let's, whoops, there we go. Let's embiggen this. All right, so that's default. Is bigger enough? You have to let me know. In the back, can you see that? Come on, there we go. Readable? Not? Probably not. Okay, let's take this all the way up to 11. Make this embiggenest. Better? Okay, so we'll work with that. All right. Okay, so the first thing that I want to do, I guess, let me kind of go back to here, and we'll start with this. Blow this up to where it's semi-readable. Okay, if you're creating microservices using Spring Boot, this is kind of your starting place on the web, right? Sometimes referred to as start.spring.io for its web location. You can use the Spring command line interface to access this. You can use curl. I like to go to the web page because it's so pretty and it makes me happy. Okay, it's not very pretty, but it does make me happy because it's really well designed. Spring is sometimes referred to as an opinionated platform, right? And I always kind of wondered what opinionated means. Well, opinionated just means that if your use case falls within that 80 to 90% use case, we try to make it just dead simple for you to get something done quick. If it falls in that other 10 to 20% use case, we still want to allow you to do it. We want to get out of your way and help you get it done quickly. It's just not quite as easy as that 80 to 90% use case. Kind of in the bad old days of frameworks, there was one way to do stuff, and you either did it the framework way or you didn't do it. That's not what this does, as you'll soon see. The initializer gives you the chance to get up and running quickly, but if you really want to switch to the full version and choose a lot of different options, you can. For instance, you don't have to bundle it as a fat jar. You can package it as a war. So if you're still stuck with an application server you can't ditch, then you're still able to use that. That's perfectly fine. We do always recommend the jar file because, again, that 12-factor manifesto, right? A couple of factors in that. I always kind of point to 3 of them as being the first among equals. One is your externalized config, one is your dependencies, where you bundle your dependencies, and one is port binding. So you expose the ports you need, the functionality you need from within your application. That allows you to use your application as a backing microservice as well, and not have external dependencies that can break out from under you. Very nice. So we'll assume we're going to go with a jar. You can choose your version of Java, supported anywhere from Java 6 to Java 8. You don't even have to use Java. You can use Groovy or Kotlin, but who wouldn't want to use Java, right? Right? Okay, well, play along. Anyway. So, has anybody ever played dependency whack-a-mole, where you have a problem and you can't figure out what's going on? Maybe you don't get a good stack trace. Maybe you don't get any kind of exceptions or errors at all, and you're just lost. So you do what you're supposed to do, right? You hit Google, you hit Stack Overflow, you're not seeing anything. And finally, you start kind of experimenting and troubleshooting. And you figure out, due to some trial and error and several days of sweat, that version 3 of library A doesn't work with version 7 of library B. Right? Nobody's lived that dream? You will. If you haven't, you will. That's really frustrating. And when you roll back library B to version 5, everything works. It's wonderful, but you realize that it's now Thursday, and you started on this problem on Monday, and that's incredibly frustrating. With the Spring Initializer, anything you see here for, let's say, version 1.5.3 of Spring Boot has been battle tested with that version. So if you choose to bring in WebSocket dependency, or Jersey, or what have you, you know that that has been battle tested with Spring Boot 1.5.3. It takes that out of your hands. You can override it, should you want to, but you don't have to, which is really nice, streamlining. Typically, I don't go through the iChart because it is quite a bit of stuff to try to go through. And by the way, you can bring your own library, specify your own version, doesn't matter, but again, don't have to. But I typically just go with the simplified version and get up and running quickly. So we'll go back to the simple version. I do want to, before I start creating the stuff that we're going to see, I want to fire up a couple of other things. And I do want to ask you, too, if you would, because in trying to repackage this and just distill the absolute essence, I've skipped a couple of parts that I usually like to live code, but I think it's important to try to focus on the meatier topics. So if you feel like maybe if you can give me some feedback, if you felt like I should have coded the first couple of things, that's great. Happy to hear it, and happy to adjust. So I'm going to go ahead and start the config service, which again, this is Spring Cloud Config. And while that's starting up, I'll give you a little bit of an explanation. Let's see. Spring Cloud Config, again, rests and rides upon typically a Git repository. Again, console, SVN notwithstanding. So you can create different key value pair files or YAML files, which will list your various different configuration properties that you want your config server to serve up to the various microservices that contact it and request such. So if you see here, you have an application.yaml file, and that's for properties that apply to all microservices. You can also specify by profile, so application-cloud in this case. So when you specify the profile in your microservices that it's running in a cloud environment, it will get these in lieu of the generic application properties. If you provide a name with your microservice to the config service when you're requesting properties, you'll also get properties that are specific to that microservice. So things like edge service, you'll get the edge service properties as well as the properties that apply to all microservices. So let me show you kind of what that looks like. If we go to here and blow this up, well, doesn't matter there. So we'll go to localhost 8888 where I'm running this. And these are just a hint of the properties that you would get for all microservices. Any microservice that contacts the config service gets these. If you were to contact the config service and say that you are, for instance, an edge service, you would get a different set, well, an additional set, which are properties specific to edge services, as well as the properties for all microservices. So again, not very sexy, but it's certainly very useful for your microservices as well as you, because it gives you a central way to manage all of those very easily. So the next thing up would be a service registry. I'll go ahead and kick that off. And again, this is a place for your services to register and to locate other microservices. So it started up on port 8761. It's getting its config from the config service as well. So then, if we go to localhost 8761, this is the Eureka dashboard. And that's blown up a little too much. Eureka itself provides capability to enable your microservices. But the Eureka dashboard is for us, the meatware. We like to see what's going on. We need to understand what's going on. And there's a lot of good information here, but the two key bits are where all locations that Eureka is running. In this case, we're running it exactly in one location, so no redundancy at all. Bad, 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 but for a demo, it's fine. As well as here, and this is where your various instances of microservices show up. Right now, we have none, so that's kind of where we begin our journey, right? So, back to the Spring Initializer. This gives you different options. It doesn't generate code per se, it generates your project. So it will create a shell project for you based on what you specify, and it does create your main application class and main method. But basically, it gives you that jump on developing the code the way you want to, and takes a lot of the cruft out of the way to begin with. So if you're a Maven developer, it'll generate a Maven project. If you're a hipster, it'll generate a Gradle project, right? Wow, this is a tough room. They're not going to get... I tell you what, my jokes are not going to get any better. They're only downhill, so, save yourself. Leave now. So with the initializer, typically you have the current version of Spring Boot, as well as a snapshot on either side of it, as well as a couple previous versions. Now here you see Boot 2.0 snapshot, which is the way that you can play with some of the reactive capabilities that my colleague Josh Long talked about this morning. So that gives you some neat toys to play with as well when you're entering the reactive space. But we're going to stick with the production version right now. And I'm going to create a quote service. Does anybody here like movie quotes or pithy quotes of any kind? Really, no one? Okay, you're my new best friend. So what's your name? Oh, Josh. Excellent. Well, that works out really well. I won't have to trade out all my T-shirts that I have with I Love Josh on them. Okay, good. All I know I lead a pretty lame life. You don't have to rub it in. But I like quotes. I like movie quotes, really cool stuff. And seriously, you guys don't. So I'm really feeling bad about myself now. So tough, you're going to see quotes. So I'm going to create a quote service which will give me a random quote, right? So every time I hit this, I want to pull back a random quote of some kind to inspire myself or to make myself smile, because not every day can be all sunshine and daisies, right? So I'm going to provide a list of dependencies that I want to bring in to my project. So the first thing I'm going to do is bring in the config client dependency so I can access my config service to load my properties. And then I want to add the service discovery client so I can access, talk to Eureka, register my services, what have you. And then I'm going to bring in Lombok because I'm a lazy developer. And that's good, right? You don't want to waste a lot of time doing stuff that others have done for you. Does anyone here like Lombok? Few? Okay. I have a love-hate relationship. I loved it, then I hated it, now I'm back loving it. So you're going to see Lombok today. But it allows you, again, to cut down on some of the boilerplate, because who likes boilerplate, right? And then because a quote repository, a quote service isn't very good if it doesn't allow you to store and retrieve quotes. So I'm going to use JPA for that. Not because it's the best option, but because, as another Josh likes to tell me, sometimes I make poor life choices. So I'm going to use JPA, and I'm going to use H2 as an embedded in-memory database. But again, anything JPA is fine, MySQL, Microsoft, Oracle, what have you. Or not even a SQL database, because we support, out of the box, Mongo, Couchbase, Neo4j, and you can bring your own, doesn't matter. But I'm going to choose H2, because it's easy, right? And then I'm going to include a dependency for REST repositories, because I'm going to be leveraging Spring Data to act as my proxy for my data store. And REST repositories allows you to expose, or it actually handles this for you, exposing those domain entities as REST endpoints. Very nice. And then let's see, what else do I want to bring in? Because I'm a crazy optimist, I'm going to bring in StreamRabbit and probably Zipkin client, because that should give us the ability to do some tracing. Should we have time? Probably not, but again, I'm an optimist. So I'll generate the project, I'll save it down, and then let's see, we'll navigate to there, and I'll open this, and open it in my favorite IDE. Don't even want to go to find out whose IDE is, what everyone's favorite IDE is. It doesn't matter. I mean, you can use Spring with any of them, NetBeans, Eclipse. We even have a special build of Eclipse called Spring Tool Suite, which is really awesome and has some really neat cloud deployment capabilities. But I love IntelliJ, so it is what it is. So the first thing we're going to do is go to our application.properties file. This is the file that Spring Boot applications will look for upon initialization. When they're creating the application context, they look for this file to see if you have any sensible default properties defined in there. We actually kind of want to get out ahead of that cycle. We want to, before the application context is initialized, we want to find a way to link to our config service and use it to bring in our initialization properties, right? So the easiest way to do that is to take the application.properties file and rename it to bootstrap.properties, because we want to do this during Bootstrap. So I'm just going to add a couple of things here, like the, let's see, Spring application name, and we'll call this cleverly enough quote service. And then I want to point to our Spring Cloud configury, where our config server is running. And I'm running that locally because I learned a long time ago never to trust conference Wi-Fi, even though it's been awesome, right? But it's really a drag when you can't get out and you're running everything in the cloud remotely. So anyway, so I'm going to go to the main application class, and I'm going to enable Discovery Client. And this is an app. This is a fully functional microservice that we can run now. It just doesn't do anything. So we need to have it do something, and as a quote service, we probably figure it has something to do with quotes, right? So I'm going to create an entity, and this is a JPA annotation because, again, we're using JPA, and I'm going to define it using Lombok because I'm a lazy developer, and instruct Lombok to give me a no-args constructor and an all-args constructor, and maybe even a two-string method, and we'll call this class quote. Didn't see that coming, right? Since this is a JPA entity, I'm going to assign or annotate my ID field and give it a little nudge with generated values so we can define our long ID. And then I'm also going to create other member variables for my quote, things like a quote text, whoops, getting ahead of myself, quote text, and a quote source. And since I'm just crazy about constructors, I'm going to add in a to our constructor for text and source. So that gets us our domain entity. Pretty easy, right? Very little code. And next I'm going to define an interface called quote repository. Repository. I should have warned you. Those of you in the front row, occasionally I will insert typos just to see if you're awake, okay? It's completely intentional. But if you spot a typo, let me know. And if you don't spot a typo, it's on you, okay? So no pressure, right? So I'm going to extend the CRUD, no, that's a different repository, the CRUD repository interface in Spring Data, and define this for objects of type quote, IDs of type long, and that gets us started, but I'm also going to annotate this as a repository REST resource. So what we have here is that by extending, I should say, this interface defined in Spring Data, again, Spring Boot is auto-configuring, right? It sees that you have JPA and H2 in your class path. It sees that you're extending an interface as defined in Spring Data, so it makes the crazy leap that you're going to want to have data access. So it provides a proxy bean here. We're going to, in turn, tell it to go ahead and expose that, our collection of objects, our collection of quotes, as a quotes endpoint. So very nice, very neat. And that's really cool without a whole lot of effort on our part, again. But we don't have any way to verify what's going on, right? We have no visibility, which is always, kind of sad. So I'm going to create a bean using command line render interface in Spring Boot. Is anybody familiar here with functional interfaces, single abstract methods? Okay, good. Command line render is a functional interface in Spring Boot, and I'm going to inject quote repository. And what I'm going to do with this is define return the lambda, which implements the single abstract method, right? The run method in this case. And since I can't spend the next 19 minutes typing pithy quotes, because then we wouldn't have any time to do any fun coding, I'm going to copy paste these and cheat a little. And also because I like to see what's going on, I'm going to take the repository, do a find all, do a for each, and we'll take that to system out print line. There we go. Okay. So let's fire this up and see what we have. What we should have is a lot of capability for very little code, as you have seen. So as this starts up, and while this is starting up, I'm going to go ahead and assume this works. Oh, not always a safe thing to do. Oh, well, it's done anyway. Okay. So as we see here, we have some quotes in our quote repository. Some really, really good movie quotes, right? Makes you want to go home and watch movies tonight, right? Okay. So it looks like it's working. So let's go out and see if it really is, because proof's in the pudding. So we're going to go to localhost 8088 quotes. And we're going to blow that up. So, oh, it is actually blown up pretty well, so you can see it. So we see some really good movie quotes here. And that's good, because it gets you the whole collection of quotes. And you can even drill in and look at an individual quote, and that's good too. But it's not random, right? I mean, it's not a very good quote service, because to see the same quote every day or to see the whole bundle of quotes every day is not very gratifying. So what I'm going to do is add that capability for some randomness. I'm going to create a REST controller, and we'll call this, cleverly enough, again, quote controller. Oops, typos. I just saved the front row. Darn it. Okay, and I'm going to, let's see, inject a quote repository using constructor injection, because again, that's better for testability, right? And then I'm going to create a get mapping for a random endpoint. Random, okay. And we'll make this public, return quote, get random quote, and we'll do a return this dot, oops, this dot quote repository dot, and this is where we kind of hit the wall, right? Because Spring Data gives us a lot of capabilities, but it can't read our minds. We have to provide some kind of hint in terms of an implementation that we'd like when we're in that 10 to 20% use case. So what we're going to do is extend our interface a bit. And we're going to give it a hint, something along the lines of select queue from quote queue, order by rand, which should return us a random order list, right, of type quote. Boom. And we'll call this method get quotes random order. And then that's enough for Spring Data to grok our intent to use the JPQL query to flesh out our method for us. So then we can do a get quotes random order, get the first one, and return it. So if all goes right, and no typos front row, we should be up and running with our randomness. And we're doing okay on time, which is good, because, again, I have a lot of stuff I want to show you. Please save questions to the end or afterward or anytime after that, because I'm really hoping to get through some kind of cool stuff here. So let's go back up here, and we'll go to our quotes. Of course, we still have the same functionality. Always good to check that you haven't regressed, right? So let's hit our random endpoint. And it's working. Hello. My name is Inigo Montoya. Okay, does anyone recognize this? If not, here's your assignment. Go home this weekend and watch The Princess Bride. It is a classic. Okay, so you're welcome. I'm going to refresh. Cool Hand Luke, another classic. Back to the Future. Anyone? Really? Toy Story? Wow. I thought I needed to get out more. Okay. The Dude Abides? Anyone? Oh, okay. Wow. Again, it doesn't get better. Okay, so we're going to now take our backing service, our quote service, I should say, and make it a backing service. We're going to consume what it produces. So we're going to create an edge service that allows us to show some of our other features, our circuit breaker, our load balancer, and what have you. Typically with an edge service, what you do is you gather inputs, or you marshal inputs and unmarshal, going the other way, when you're trying to streamline a connection, streamline a capability that you're providing, a subset of data and capabilities you're providing to maybe a mobile client, for instance. But I'm actually staying pretty close to a one-for-one just for the demo. So you'll see a lot more of the pass-through, and it gives me an excuse to show you some of the Zool stuff as well. So I'm going to change this from quote service to edge service. Again, naming's hard. And I'm going to remove JPA, H2, and REST repositories, because we need those for our backing services, but we don't need them for our edge service. But I am going to add in dependencies for histories, because, again, we want to do some circuit breaking here. And I'm going to bring in Ribbon for client-side load balancing, and Netflix Zool for intelligent and programmable externalized routing. So you're not embedding that in your application code. And then I'm also going to bring in web dependency, so we can define a web API. We had that actually as a sub-dependency, a nested dependency in our REST repositories before. And then I'm going to bring in actuator. Not that I am sure I'll have time to do this, because, again, I'm an eternal optimist. So, and let's generate the project. We'll save it. And we'll go pull it up. Boom. Open it. There it is. And we'll open that in our favorite IDE. Oh, he was supposed to come in and spell me at this point and take over. Good help. So hard to find. All right. So the first thing, again, we're going to do is go to our application properties file. We're going to rename it to bootstrap.properties. Did I get that right? Oh, good. It is right. Okay. And then I'm going to give it, well, first I'll point it to the Spring Cloud config URI, which, again, is http://localhost 8888. And then I'm going to give it the name of, again, cleverly enough, edge service. And then we'll go to our main application class. And I'm going to annotate this as a Zool proxy. You're probably wondering at this point why I didn't annotate this as a discovery client like I did the other service. That's because the Zool proxy annotation is actually, a meta annotation. Because Zool is Eureka aware, right? So it kind of assumes that you're going to want to use the Eureka service, or any kind of discovery backend, if you will. So it enables the discovery client annotation in with it, as well as circuit breaker. So you get kind of 3 for the price of 1 with that, which keeps your code nice and neat. Now, as it is, I can run this, and this will register with Eureka. And this allows me to show you a little bit of a hint of the power of Zool. You familiar with Zool? Hittite mythology? No. Ghostbusters. Ghostbusters, okay, yeah, big nods, yep. Okay, well, it's infinitely cooler when you read about, or see it in Ghostbusters than when you read about it anyway. So we see that we're started up on port 8086, so we know that we have successfully contacted our config server and gotten that information from it. So now if we pull up another browser tab, because you can never have too many browser tabs, right? And we go to QS quotes, this looks awfully familiar, right? In fact, it looks a lot like that. Oh, except again, typos. Computers are so literal. Okay, so if you look at these two, you can see that there's some URI translation going on. And that's pretty cool, because all we did, if we go out here and take a look at our edge service properties, we can see that we've defined some Zool routes. So the first one in particular is important. We have anything, when we're hitting our edge service and referencing a path with QS in it, our Zool proxy will in turn route those requests to our backing service by the name of quote service. One of our instances of quote service. In this case, we're only running one, so that simplifies things a bit. But again, it's Eureka aware. So it will find that in that manner. Whoops, let's see. Let's zoom back out, and we'll go back. Oh, I thought we blew a bulb or something there. And you see that it actually works equally well for anything you can address from our backing service. So we can even get directly to our random quote endpoint. Now, that's what's called a micro proxy. So if that answers your use case, you're done. You have really little to do in terms of an edge service and how to deal with it. But in most cases, it doesn't, because again, you're going to be gathering data from multiple backing services and munging them and manipulating them and consolidating them in a way that's very tight and compact as an edge service. So we'll assume you want to do that because that makes it a lot more fun anyway. I'm going to go ahead and again define my quote entity here. So let's see, data, we'll do a no args constructor, all args constructor, toString, and we'll call this again, cleverly enough, class quote, private long ID, private string text and source, and just to be safe, we'll go ahead and create our toArg constructor. And now, in order to access this, I'm going to do something that isn't, typically what I do is try to stay close to best practices, but sometimes I veer from that just to make it a little more apparent what's going on behind the scenes. This is one of those cases. So what I'm going to show you is a little bit of a long way around the barn, so to speak. So please don't say that I said this was a best practice and implement it in production, but it is kind of instructive, I think. So I'm going to, again, I'm actually going to create a load balance bean. Again, this is using Ribbon for our client-side load balancing. And we'll create a REST operations bean. Let's see, REST operations, return new REST template. Again, you write to the interface, right? So that gets us our REST template that then we can use here. I'm going to, let's see, create a class called quote controller and private, let's see, REST, let's see, REST template. Actually, you know what? REST operations, and constructor. And then we'll do a, let's see, at REST controller. I'm trying to go so fast because I want to make sure that we cover up to a certain point, and I'm racing the clock here. So we'll do a get mapping, and we'll call this endpoint Quotorama, because I'm really bad at naming things. So we're going to make this a public method returning quote, get random quote, and now we will do a return this dot rest operations dot get for object http:// quote service / random. And you're probably noticing at this point that doesn't seem like it would be a valid URI, right? But remember, this is a REST template that is Eureka aware. So we have a Eureka lookup built in. So since we've registered our quote service, a microservice by the name of quote service, an instance of it anyway, with Eureka, we can locate that via our intelligent routing, via our client-side load balancing. And what should happen at this point is that if I restart this, we should be in business. And I'm going to go ahead and add a couple of things here while that's rebooting. Restarting, excuse me. Okay, now while that's coming up, I do want to point out one other thing. I've defined another Zool route. I call it demo, but it doesn't really matter what you call it. The important thing is that I'm specifying a path for my edge service. So if you have /quote in your URI, in your edge service, it should forward to, in this case, a local endpoint called Quotorama. You can also, as you see down here, point to any public API. It doesn't really matter. Zool is smart enough to handle that. So now that we're restarted, yay, successfully, let me go back to here, and we will now go to Quotorama, and we see that our local endpoint is working. Always good to verify, right? And we'll hit our quote endpoint. So now we see that everything is routing properly. I probably will not have time to get into showing you some of the routing via Zipkin, via Spring Cloud Sleuth. But what I really want to do is show you that circuit breaker, because I think it's a really nice wrap-up of kind of the key bits that you really need, again, for that minimum viable product. So let's go back to our code. And let's see. Here we have our method for retrieving a random quote from our edge service. What happens if that backing service goes offline? What happens if all instances of that backing service go offline? You'll get something that really looks ugly, right? You don't want to pass on errors directly to your end users or your end user applications. So what we're going to do is leverage Hystrix. And we're going to designate this a Hystrix command with a fallback method. Now, in order to designate a fallback method, obviously we need a fallback method. So that's our next stop. Get default quote. We'll return new quote. And we need a new quote, right? As luck would have it, I've defined a default quote in my properties that the config server is providing to our edge service. So I'm going to access that value using the @value annotation in Spring. And we're going to point that to our quote property and assign that to default quote. And then we can create a new quote using our default quote. Let's say you, me, and everyone. This is a good quote, right? Everyone will want this quote. So now the only thing we have left to do is take our method name and assign that as our fallback method for Hystrix. Right? So let's see, 3 minutes. We have time. I'm going to just... What's that? Oh, gosh. Yeah. Oh, no, wait. Who said that? You're not even in the front row. That's amazing. If I had a T-shirt to give you, I'd give you one right now. Okay, I get excited and I just skip over stuff wholesale. So this should work. I'm going to go ahead and start this, and then I'm also going to find my Hystrix dashboard so I can show you something kind of cool with that. So I'm going to kick this off at the same time. What could go wrong, right? Live demos, everything always works perfectly. So once this comes back, okay, that's started. So now, if we go to here and we will refresh, so we have a quote. We're getting our quotes just fine. Everything's great. I'm going to localhost 8010 Hystrix, and that's gorgeous, right? Really sad, but again, not designers who made this. Localhost 8086/quote, right? Edge service. And we'll monitor the stream. Oh, silly me. I actually need to do Hystrix stream. That works a little better when you tell it where to monitor. Great. Okay. So now I'm going to peel this off and jam this against this side, and peel this off and jam this against that side. So now we can take a look at these. So what happens when everything's working right? So I'll do a refresh, and you'll see the green ball grow, and you'll see the number of requests it's servicing grow. So everything is working fine. Your distributed system is great. But what happens when you kill that backing service? Because who likes that backing service anyway, right? So I'm going to kill that. It is well and truly dead. So now what happens? So when I refresh this, we get our default quote, which, as you might have wondered what that was, whatever the question, coffee and chocolate are always the answer. I personally can just go with coffee, but that's fine. Chocolate works for people. So we'll refresh, and as you can see, we get a lot of red requests, right? once it gets past a point of so many failures in so long a time, which right now it's set for the default value, I think 20 failures in 5 seconds, it will open that circuit. Now, what happens when a monolith fails? All of that demand backs up, right? And then when the monolith is brought back online, what happens to the demand? It just hammers the monolith. So you get into this weird cycle that the monolith's up, the monolith's down, the monolith's up, the monolith's down. And a good circuit breaker will take care of that for you by slowly restoring the capabilities. So what happens with Hystrix is once every so many requests, again configurable, it'll go out and try to send a request to the failed backing service. When that circuit is open, it goes and tries to reestablish it. And once it does reestablish it, doesn't just shove all of the traffic to it, it gradually restores that traffic. So as you can see here, you'll start to get a few requests coming in. And by the way, the default timeouts as far as notifications go is on a 30-second notification. So it may take up to 30 seconds for your backing service to notify your Eureka it's back online, and up to 30 seconds for the edge service to pull it. Again, that's the default. You can change it however it suits you. I just left it as the default. So again, it takes a little while to come back up. And of course, it's not going to come back up in time for me to do this before I cut back to the slides. But we'll go back to the slides here. Let me switch back because I'm out of time, sadly. And we want to wrap it up. I sometimes forget to do this, so I want to make sure you get these. So some helpful links. I always start with the Spring I/O guides because the guides are sometimes very long and in-depth and give you a lot of good information, but sometimes you just need to go and get a bite-sized chunk. How do I use Redis with Spring Boot? How do I leverage Hystrix? And they'll have 10 to 15-minute short snippet projects for you to do and quickly come up to speed. That's kind of nice. Again, all of the code is open source, so download the bits and play with them, but download the code if you want to. And if you see something that's not working like you think it should, reach out and ask questions. We're on Getter as well. Maybe you're not using it right. It happens. Or maybe you are, and you've identified a gap that we're working on, and that's great. Or maybe we're not working on that yet, and you could start working on that as well, because we do take pull requests. I mean, we're very community-driven. But do ask first so you don't waste a whole weekend working on something and somebody says, yeah, it's going in the next release. We already have it coded. And then, of course, finally is the repo for all this. It's a meta repo that points to all these and more. So in summary, microservices can be hard, but they don't have to be. Leverage the enablers that help both you and your microservices get along and understand and keep track of everything in your system. Build for speed and resilience. And remember, Netflix does it, so can you. A lot of folks say, well, yeah, but that's Netflix. We don't have those kind of engineers in my company. To which Adrian Cockcroft frequently would respond, where do you think we got them? So you can do this stuff. It's not that hard. Be another Netflix. So thanks. Thank you so much.